Let's continue our review for the Unit 1 lecture exam in astronomy. And so now we're going to review lesson number 3 on cycles of the sun and the moon. So make sure and read your lesson objectives for this lesson. And then you'll notice that out of your textbook, Essential Cosmic Perspective by Bennett, you need to be reading Chapter 2, sections 2, 3, and 4. So first, you need to know about the types of planetary motion. So objects spin and objects orbit. So we've talked about this already, that objects are spinning on their axis, and then objects are orbiting around something else. So that the moon is spinning, the moon is in orbit around the Earth. The Earth is spinning, it's in orbit around the sun. The sun is spinning, the sun is in orbit around the Milky Way galaxy. Okay, so how there's differences in different planets in both their orbit and their spin. So one thing, let's talk about the spin. You have the speed at which it's spinning. So some things spin slowly, some things spin quickly. Okay, another thing is the tilt of the spin axis. So Earth is tilted at 23 degrees. Venus is actually tipped upside down, like that. So you have differences in the spin rate and the spin angle. Okay, what about the orbit? So you have differences in the orbital speed as you go around the sun, and then there is also the orbital tilt. So that if this is the sun, and then you were to draw a perpendicular to it, that's the plane of the solar system. And then the various planets are tilted in their orbits with respect to it. So like, for example, Earth sometimes might be higher in its orbit around the sun, and sometimes it's lower. Now, it's not very much, so it's only about 5 degrees. As a matter of fact, for all of the planets in our solar system, they're all tilted at different angles, but all within about 5 degrees of the plane of the solar system. But this is going to be very important when we talk about the moon, because it's going to explain some stuff which we'll talk about in just a moment. Okay, another thing would be the speed of the orbit as it goes around, the tilt of the orbit, and the eccentricity of the orbit. So that eccentricity varies between 0 and 1. An eccentricity of 0 means that it's a perfect circle. As the eccentricity gets larger, it becomes more and more stretched out. You can never get to an eccentricity of 1. When you get to an eccentricity of 1, then the orbit snaps, and then it turns into a different kind of orbit, which we'll talk about later. So it varies between 0 and as close as it can get to a 1, and then that's the more stretched out. All right, so now let's use this concept of spin and orbit in order to explain different phenomenon as seen from Earth. So the first one is going to be, why do objects appear to come up in the east and then set in the west? So which of those two things, does it have to do with the spin of the Earth, or does it have to do with the orbit of the Earth? Okay, and the answer is the spin. Okay, so that Venus, because it spins backwards, that means that the sun appears to come up in the west and then sets in the east. All right, monthly phenomenon. So you need to be able to explain to me how do you, why does the moon sometimes does it appear to be black, sometimes it appears to be fully lit up, and sometimes it's half and half. Those are the words I want you to know for the exam. Okay, so I'm not going to ask you about waxing, waning, gibbous, so all of those technical words. I'm not going to ask you about that. So I'm going to say, how does the Earth, the Sun, and the Moon how do they have to line up in order for the moon to be fully lit up? Okay, you should be able to draw pictures on the exam, or if I give you a picture, you should be able to interpret it. So if I gave you a picture of the sun and then the earth and then the moon, I could ask you what phase would the moon be in. And so the moon would be completely lit up by the sun, and so half of it would be in darkness on this side over here, but then this side over here would be completely lit up, so it would be a full moon. On the other hand, if the moon was over here, okay, half of it is still lit up, so this part over here is completely lit up, but this part would be in darkness, so as seen from the earth, it's going to be completely black. If we put the moon up here, okay, half of it is going to be lit up, half of it's going to be in darkness, so from the earth you're going to see half and half. Okay, so that's what I want you to be able to do on the exam. All right, yearly changes. So now let's talk about eclipses of the sun and eclipses of the moon. So you have a solar eclipse and a lunar eclipse. Okay, the solar eclipse is going to be when the moon gets in front of the sun. So this one over here, this is going to generate a solar eclipse. This one over here, that's going to be a lunar eclipse. So let's first talk about the solar eclipse. Okay, it doesn't happen that often. The moon goes around the earth once every month. So that means that theoretically the moon could be in front of the sun 12 or 13 times per year, and you could have an eclipse, but it doesn't happen. So the reason why it doesn't happen is because of the tilt of the orbit of the moon. So that sometimes the moon is above the plane and sometimes it's below. So let's say that if the sun is over here, then you can see that the shadow of the moon would miss the earth. If the sun was on this side over here, the shadow of the moon would miss the earth. So there's only certain times of the year when things are going to line up correctly, and that's going to be 2 times per year. So we have eclipse seasons. Twice a year is when the moon in its orbit would be exactly in between the earth and the sun. Now, lunar eclipses, they happen more often, and that's because the earth casts a larger shadow than what the moon does. And so the earth can cast a shadow onto the moon, and that's when you're going to see a lunar eclipse. Okay, and then this one here shows the umbra and penumbra of these eclipses. You're not responsible for those words on the exam. Okay, let's take a break. When we come back, we will continue. Now we're going to talk about the seasons and what causes them.